horse feed in pounds, weight of horse, the food it would require. Remember that?
Mm.
Okay. Keywords, metric, lower bound, upper bound, imperial, conversion, exchange rate. In this chapter, you will learn how to convert between units in the metric system. Meter to centimeter, kilometer. Find lower and upper bounds of the numbers that have been quoted to the given accuracy. Uh,
Oh, so
Sorry.
it could have been like the highest and like the lowest, so we could round it up.
Yes, the acceptable range. For example, if I say there was a football match and 40,000 people attended the match, and you would say exactly 40,000, so I would say that it is close to the nearest 1,000.
No, no, no,
That
no.
means that means there could have been 40, 1, 2, 3. And when I say close to nearest thousand, we always do plus minus 500. So
So,
if I am saying, yeah, yeah,
so it could have been 41,000.
it could have been lower end would be 39,500 and the upper end would be, it should be 40,500.
Did you say the thousands or the hundreds?
Nearest thousand.
Oh, so that's why we have to check the hundreds. So, no, no,
Whatever we say, we take half of that. If I say nearest 100, I would have written plus minus 50. If I say nearest 10, I would write plus minus 5. Now, the catch is here. In this case, we will write 39,500 and one less than this. So 40499.
because if it was 500, it'd be 41,000.
Yes. So that is the only reason. Lower end is always uh, minus the given accuracy, and upper end is one less than that. And in some cases, we'll discuss those cases. We can use 40,500 exactly.
If it's rounding it up higher.
We would deal with that with this sign. We'll say 39,500 is less than equal to x is less than 40,500. We don't put that equality sign here. And then there's difference between data. I'm talking about number of people. Suppose I was saying that this is the length. So length could be in decimals, number of people cannot be. So simple conversions, kilo to hectare is into 10. And then deca, milliliter, grams, deci, centi, and milli. Basically, wherever you see K, that means three zeros. Wherever you see milli, that is divided by 10 centi is 100, deci is 10. So centimeter to millimeter. Do you know these? Centimeter to millimeter is into 10.
Yes. One of
Centi
my teachers told me that it's kind of like a staircase, that as you're going up, well, it's dividing by it, and then when you're going down, it's multiplying,
that's right.
like the measurements.
That's right. And what about the square units?
Well, it's still gonna be squared.
That's right. So centimeter to millimeter is 100 is 10. And centimeter square to millimeter square is 100. And centimeter cube to millimeter cube
1,000.
is 1000. Now these graphs are very helpful. Sometimes we do not have like integers like the one in centimeter to millimeter. In case of inches, 16 centimeters is equals to 6 inches. So if I would ask about 1 centimeter, so that would be some decimals and rounded number. So graph is very helpful in that case. Understanding units. So we already know that we can skip this part. Like 1 meter is equals to 100 centimeters. Measurement. If we are measuring length, we have units: millimeter, centimeter, meter, and kilometer. Okay. For example, if you are telling someone to bring soft drink, will you tell them 1000 ml or you'll say that 1 liter?
1 liter?
1 liter. Are these two exactly equal?
Yes.
But we do know that which unit is acceptable in which form of conversation and context. So I would say that my workplace is like 6 kilometers away from here, and I would not say that 600,000 centimeters, although both of them are equal. So we measure length in millimeter, centimeter, meter, and kilometer, and the conversion is as follows. And when we talk about mass, we do have milligrams, grams, kilograms, and tons. Capacity, we should know these conversions because it will not be given in exam, but definitely asked. So capacity, the inside volume of a container. So we talked about length, mass, and now volume. Milliliter, centiliter, and liters. 1 ml is equals to 1 centimeter cube. And centi means 100. Centi is 10. So 1 centi is 10 ml. And 1 liter is 1000 ml. So 1 liter is equals to 100 centiliter. Area. Square millimeter, centimeter square, meter square, kilometer square, hectares. Hectares is 10,000 meters. If I talk about myself, I just remember this. Whenever I have to convert hectares into centimeter and millimeter, it is always easy for me to first convert it into kilometers and then convert back. If I have to convert hectares, let's say I have 100 hectares and I have to convert it into centimeter square. So that will be difficult for me. I'm talking about myself. So hectares to kilometers, I know that 1 hectare is equals to 10,000 meters square. So 100 hectares would be 10, 1, 2, 3 meter square. Now I have these meter squares. So meter to centimeter square, I'm very comfortable. I know meter to centimeter is into 100. And when it is square, it would be 4 zeros. So I actually don't have to memorize everything directly. Like kilometer to centimeter, kilometer to millimeter, kilometer to meter. We can interconvert them.
So just like kind of steps.
Steps, yes. So volume again, millimeter cube, centimeter cube, millimeter meter cube, and mLs. ml is equals to centimeter. Express 5 kilometers in meters. Worked example, but we'll solve these. So 5 kilometers in meters is 5,000 because 1 kilometer is 1,000 meter. 3.2 centimeter to millimeter
30.
times 10, 32. Centimeter square to millimeter square.
It's going to be times 100 or divided by 100 squared.
Yes, divided by 100 square. That means 4 zeros. So 1, 2, 3, 4 zeros cancel out and we left with
100.
200. Express each express each quantity in the unit given in the bracket. Okay, 4 kgs to grams,
4,000.
4,000. Okay, for now, what we will be discussing is multiplied with or divided with. For example, when we are discussing with each other, I'll expect that you say From 4 kgs to grams, you'll say multiply it with 1000.
Okay.
Kilometers to meters?
Multiplied by 1000 again.
Yes. Millimeter to centimeter?
Divided by 10.
Divided by 10. Now the actual answer. 81 millimeter to centimeter.
8.1.
8.1. Actual answer, gram to milligram. Can you read that? 7.3.
So it's going to be 0.00.
No, it's
No,
the
no,
other
you
way.
times it because it's going down. So it's going to be 7,300.
Yes. Kgs to tons.
So it's also 57,600.
5.76.
But isn't tons larger?
Tons is larger. We're converting from kg to ton. So we divide it.
Divided by 1,000, right?
Yeah, tons is larger. Whenever we go on the upper side, we divide. 1000 kg is equals to 1 ton.
Oh yeah. So okay.
So look at this. 1 A, B, C, you knew, multiply or divide. D, yes. E, yes. In F, you still knew it is 1000. But sometimes that happens that in 2000 or divide by 1000. So we'll only get one chance in exam. We'll read it carefully and we'll score full. G part answer. Is it readable?
It's yeah, times by 100.
Yes. 210. Now 2 tons to kgs.
So this time it's timesing. So it's 2,000.
2000. 140 centimeters to meters.
So uh so it's going to be 1.4.
Very good. Grams to kgs.
Uh, 2.024.
2.024. This doesn't look nice. 2.024. Milligrams to grams.
So it's going to be 0.121.
0.121. Yes. 23 millimeters to millimeters.
Oh, so I remember this one being 1,000. So it's going to
Yes. Now you remembered that was 1000, but what I had to go through is I first multiply it with 100, that is centimeter in my mind, and then another 10. So that is 1000 for me. So 23, 1000, but you remember that directly. I have to go through them step by step. Centimeters, 3 centimeter and 5 millimeter. So we converting them in millimeters.
Oh, so I can just add the 5 later. So I can just have to do the 3.
Very good.
So that is times by 10, so 35 millimeters.
Very, very good. 35 millimeters. And 8 kilometer and 36 meters.
So 8,036.
Yes. 9 grams and 77 milligram to grams.
Oh, 2 grams. Okay. So that one, 77. So it'd be 0.07. So 9.077.
Very good. Okay. Now arrange these in ascending orders. Let me just copy them. This is, this is, 3.22 meters, 3 whole 2 by 9 meters, and 32.4 centimeters. Again, it would vary person to person. In my case, I do understand them when I convert all of them in same unit.
So it'll have to be meters.
Very good. So both two of those are already in meters. So it's wise that we convert one of that
So
into in
0.324.
0.324 meters. So obviously this one is the smallest. And when we write the final answer, we write the original number.
And then it's going to be 3.22.
Now I'll have to check what 2 by 9 looks like.
I think
So
it's
yes, yes,
continued.
you're right. That continues, yes. So meters and 2 by 9 meters. Write the following volumes in order, starting with the smallest. So question number 3. So what should be our final unit if we have to convert them in
I
same
think
unit?
it should be liters.
Liters, okay. So the
Because
first one is 0.5. Last is already 0.65. Now what about these two?
uh so 0.78 and
0.78 and
0.125.
0.125. Now it is very clear. So the smallest being 125 ml. Second largest is 1 by 2 liters. Third largest is 0.65 liters. And the last one is 0. No, sorry, 780 ml. Okay. How many how many 5 ml spoonful can be obtained from a bottle that contains 0.3 liters of medicine?
So let's convert the liters, I guess. So it would be it's 300.
Yes. And
300, so 300 divided by 5, so it's going to be 60.
60, yes. Express each quantity in the given unit in the brackets. So we're converting them in millimeters and kilometers. So one part is like two questions. So when I change meters to millimeters, that was 1000, 14230. And when we change it to kilometers is 0.142, no, 0.01423. Try B part.
So for milligrams, it's going to be 1,906. And then for tons,
It is not 1906. That's one more zero. 19060.
oh yes, 1,960. No, 19,060.
Yeah,
Yeah,
sometimes it is actually easy to write
yeah.
than speak.
So 19,060
And tons.
and be 0 point. First, I have to change it into.
You can just tell me that which number are you multiplying or dividing with.
Well, first I'm trying to change it into kilograms, so I divided it by 1,000,
That's good. Then
and then now I have to also divide it by, I think it was 1 million.
very good. So for now, may I write 19.06 into 10 raised power minus 6?
Yes.
And the next step, 1.906 into 10 raised to the power minus 5.
But isn't it both the same?
No, 1 point. That is 19.0. This is 1.9. Let me
Mhm.
write that again.
Yeah, but isn't it?
19.06. When we talked about a million, this was the case, right? And if I write 1.906, I would be writing into 10 raised to the power minus 5. Remember standard form
Yeah, but
indices?
won't the results be the same?
Yes, they're same.
So which
Like
one are you
if I write 20 into 1 or I write 2 into 10,
same?
same.
So which one are you
That
right?
is standard form. If we have to choose the second one,
Okay.
this is standard form. Mostly the question would ask so. Look at question 6. A cube has sides of length 3 meter. Find the volume of the cube in meter cube.
So first of all, 27 meters is the volume of the cube in meters. So it'd be A is 27,
27, yes.
and then B, since it's centimeters cubed, it would be times 100 cubed as well.
Yes. So 27 million.
Hmm. And then
And C
27 million times 10, basically 10 cubed.
10 cubed. So may I write 9 in this place?
Well, yes, because you're adding them,
Yeah.
exponents.
Now these are just the numbers. If we have to write them in standard form, decimal would appear right after the first digit. So 2.7 into 10 raised to power 7. And this is 2.7 into 10 raised to power 10. The average radius of Earth is this. Find the volume of Earth using the numbers. So it is again the same conversion. We just plug in the radius and then we convert it into kilometer and meter and millimeter. Look at question number 8. The dimensions of the cone in the diagram are given in centimeters. Calculate the volume of the cone in centimeter cube.
For
Do you
question
remember it?
and it was also giving us the volume. Why?
Please say that again. I
For
missed it.
question 7, it was also giving us the volume for it. So is it just to like figure out the full? Oh, okay, yeah, finding the volume of the earth. So yeah, okay.
Formula was given. So this was like very similar to question number 6. That's why I
Yeah,
skipped it.
yeah, okay.
Just in order to try different questions. The dimension of cone shown in the diagram are given in centimeters. Calculate the volume of the cone in centimeter cube, millimeter, and so on. Now this is 1 by 3 into area of base into height. So 1 by 3 into area of base is pi r square into height is 12. So I'm not changing pi. So that is 3 into 3 divided by 3 into 12. I'm getting 36 pi. 36 pi centimeter cube. We can also change it. We have our calculators. Now millimeter cube. Centimeter to millimeter. What do we do?
We're going to times it by 100, 10 cubed. So it's gonna be
Cube,
1,000 times it by 1,000.
right?
Mhm.
And then kilometer cube.
And that one is just we can go from the centimeters and then to the meters and then to the kilometers.
Yes.
So that would be 0.36 times uh 0.36 divided by 1,000. No, 1,000 cubed. So it would be
You're
one.
going from centimeter to kilometer.
I did centimeters to meters and then to
Good.
kilometers.
And then to kilometers. So from centimeter to meter, that's 1000. And then, sorry, that's 100. And then again 1000. So these are five zeros, 100,000.
And then cube that.
And then cube. Now what do I do? Multiply or divide?
We divide.
We divide. So 3, 6 pi into 10 raised to power. These are five zeros. So 5 3 times is 15 minus 15, right?
Why? Well, aren't we
Because
like,
we're dividing it.
yes?
Five zeros. May I write these five zeros like this?
Mm-hmm.
So this would make it 10 raised to power 15. And when it's in the denominator, that becomes minus 15 when you bring it in the numerator. Like 3 6 pi over 10 raised to power 15. And next step, 3 6 pi into 10 is from minus 15.
Mm-hmm. But why 15?
And why 15? Because that was five zeros cubed,
Oh,
making it 15 zeros.
okay.
And the instructions are given at the end when we have done everything. He said, give your answer in standard form to three significant figures. So that would be 36 into pi is giving me 113.09. So this is 113 centimeter cube. So whatever we're doing with this 113, and that would be in 2000. So 113, 123, and that is divided by 15 zeros. So 113 into 10 is for minus 15, and converting it into standard form is 1.13 into 10 is for minus 13. Applying your skills, Miss Molly has a jar that holds 200 grams of flour. How many 30-gram measures can she get from the jar?
So it's just 30 divided by 200, 200 divided by 30.
So I'm getting 6.6. My answer is 6. How much would be left over?
0.6.
No, grams.
Oh, yes. So, oh. So just 30 times 6, which is 180, so 20.
So 20. Now, if that was the question in exam, what would you do? This or
Working.
this?
Working and the answer.
Yes. This is left in an office building. Maximum load is 300 kgs. The lift won't start if it holds more than 300 kgs. Thomas is 105, 65, 55, 80, 70 are waiting for lift. Can they all ride together?
We just have to add them all together.
105 plus 65 plus 55 plus 80 plus 70 is 375.
So no.
So no, 375 kgs is a no.
Can we just write no, or do we have to also show like 375? Or is that part of working?
That is part of the working, because how do you reach this no?
So they have to know. Okay.
You added them. They already know. The examiner is asking you the question, he already knows the working and everything. He needs to make sure if you know it.
Okay.
He wants to make sure that this is not a guess. And how did you answer that no? You added them in your mind or you added them on the calculator. You just have to write it on paper.
We can just
As
write the answer, like 375. We don't have to also like show the
no,
added.
yeah, yeah, we can write 375 and then no.
Okay.
Like we don't have to write 105 plus 65 plus 55 and so on. We don't have to go through that. B part. Mandy says she will use the stairs. Can the others go safely into the lift?
No, still no. It's
Still
still
no.
305 now. So
Very good. So we'll say 375 minus 70 is equal to 305. No. Rashid says he will wait for the lift to come down again. Can the other four go safely?
yes,
Yes.
that's gonna be 495. I know 295. So you can go.
Yes. Okay. These were masses and lengths and volumes.
That's
Now
time.
time. How many minutes are there in 1 hour?
60.
How many seconds are in 1 minute?
60.
How many milliseconds are in 1 second?
60.
1,000.
1,000.
Yes.
Why?
1 hour is equals to 60 minute. 1 minute is equals to 60 seconds. 1 second is equals to 1,000 millisecond. M means 3.
Why is
Small
that?
m. That's milli. Like kilo means into thousand.
Mhm.
Capital M means mega. That is 10 raised by 6. K is 1,000. M is 10 raised by 6. Small m is 10 raised by minus 3. Because the examiner asked milliseconds. Suppose microseconds, it would be 10 raised by minus 6.
Then how is conversion, for example, let's say milliseconds to minutes? So how would that work? So we just have to times it by 60?
60,000.
So we just have to times them. 60 times 1,000, so 60,000.
Yes.
Okay.
Sarah and John left home at 2:15 p.m. Sarah returned at 2:50 p.m. and John returned at 3:05 p.m. How long was each person away from home?
So
Sarah and
Sarah
John left
was
home at
35
2:50.
minutes.
Sarah returned at 2:50. John, how long was each person away from home? I think we'll find the difference and divide by 2. Sarah is 2 hour 50 minutes.
So yeah, it was 35 minutes for Sarah. And then we just write how long he was away. And then for John, it would be um 40, 50 minutes away.
Hmm, 35 minutes, yes. And 50 minus 15 is 35. Okay. So actually, we're just finding the difference between these times. We need to know how we subtract times. So in case when you subtract times, how do you take this carry? For example, we are subtracting 3 hours and 15 minutes, and I'm subtracting 2 hour and 37 minutes. Now we need to know that when we take the carry, when this is 2, this becomes 75. That is not becoming 11 because I've converted this 1 hour into minutes. So now we're dealing with 275 and 237. This is 6, that becomes 15, 7, 8, 3. So this is 38 minutes.
Will this
And there's
like
also the
large ones, like really large numbers? Let's say like if it was 2:37 and she arrived back at like 7:15, that still work?
7:15 and 2:37. We have to subtract these two.
We can just subtract it straight up.
Yeah, but I need to convert that 15. So I'll take a carry. This is 6 and there goes 60. So this becomes 675 and then 237. But the difference is 38 and 4. 4 hours and 38 minutes.
Oh, so we just always have to convert like the highest number. So that's it.
Yes.
Okay.
Can you see this button right above my finger, that
Yes.
zeros and commas? Now here's the trick. Do you have that in front of your calculator?
No, I don't have it in front of me.
Okay, I'll try and show. Now this is 7:15 and 2:37. So 7:15 minus 2:37. I'm writing 7:15, but when I write 7, can you see that 7 blinking?
Yes.
And then I'm just punching in this button again, which I showed you. That's a dot. And then 15 and that same button again.
Oh, so it just calculates time basically.
Yes, minus 2
Oh,
dot and 37 that dot.
are we allowed to use that?
Yes. How would you know? And equal to. See, 438.
Oh,
Now, what is this actually? When we are talking about degrees, one complete circle is 360 degrees. And then when we split this 1 degree again, we call it whatever we call it. I'm not mentioning it to avoid any confusion. That is 60 parts. And then we split that 60 again. That is again 60 parts. So that works for us because hours is equal to 60 minutes and 1 minute is equal to 60 seconds. So these dots are giving us the correct answer. This is actually not for time.
yeah.
This button is for degrees, angles, but that works 100% for us. Now, what will we do in exam? I've subtracted these and I've quickly checked it is giving me 438. Yes. So I
Also,
made no
we're checking
mistake.
it. We
Yeah,
can't just do that to get the answers.
we are showing the working. And during exam, we just checked and we were confident that yes, this is the answer. If
Okay.
there was any difference, we'll quickly recheck. A train leaves at 5:35 and arrives at 18:20. How long is the journey?
So we can just use the calculator.
We need to show the working and we'll make sure with the calculator. So now this is 17 and 60 goes over there. That makes it 80. 80 minus 35 is 45 and 17 minus 5 is 12. So 12:45. So I'm using calculator. 18:20 minus 5:35 is 12:45. We need to be careful when the time actually crosses the 24 mark. Let's say someone left X at 10:12 a.m. and they reached Y, this is p.m. Monday. And they reached Y at 2:12 Tuesday, or let's say 2:12 a.m. Tuesday. How long did they travel?
Oh, so it's another 24 hours though. So we have to convert that into military time, right? The 2:12.
We can do that. We can do like in the same way as well. See, this is 10:12 p.m.
Mm-hmm.
So when the time is passing, time is passing, time is passing, it passes through this 12, right?
Mm-hmm.
So I know what this time is, then I'll add this time to that.
So it's gonna be 14:12.
Now, luckily, this is 12:12 on both sides.
Just
So
an
see,
hour. That's
11:12, 12:12, 1:12, 2:12. These are completely 4 hours. But I cannot subtract these two or I cannot add these two. I have to go through this. So what I'll do, and let me change this to make it different, or let me make it 35. So this is 12. I need to know what this time is. Minus 10, 12. So we take that carry. This is 11 and that becomes 60. 60 minus 12 is 8, 48 and 1. So this is 1 hour and 48 minutes.
and then we
And then on the other end, this is clearly 2 hours and 35 minutes because we started from 12. We don't have to subtract that. So total time is 235 plus 148. 8 and 5, 13. 4, 5, 6, 7, 8 and 3.
it's
So
gonna
they
be
took,
4 hours and
yes, very good. We take that 60 out and 3 and 2. 4 hours and 23 minutes. And then the one which you were talking about, let me write that again. 10:12 p.m. to 2:35 a.m. You use the word military time. We would say 24-hour clock. So this stays 0235 and this is 22:12. But still, this was Monday and this is Tuesday. So I have to go through 24. So this is 1 hour 48 minutes and that is 2 hour 35 minutes. If this would have been same day, we'll subtract 22:12 and 0235.
for the one above, where you went to like the 12, can't we just like from the 12, can we just like for example, since it's 2 a.m. I believe, can't we just make it 14? Since it's still continuing 14 and then subtract it like that with the 10?
When you do so, you have to be careful because you know what you're doing. And the easiest way is just lift your chin a bit and look at the clock at the wall displayed in the exam hall. Like if you're looking at that,
Oh, so it's like a cheat sheet kind of like.
like we'll not make the mistakes if we're looking at the needles. We'll somehow know that it is 4 hours something, not 8 hours something. Because we know 22:12 is behind 24 and 2:35 is after 24. Let me draw that. I know that 22:12 is somewhere here. 22:12. And I know that 2:35 is somewhere here. And we know that it is passing through 2400. So I'll know it is somehow close to 4 hours, not 8 hours. If we are subtracting 22 and that, we are actually getting this, which is not required because
Mhm.
it started at this time and ended at that time.
But I
So
mean,
I
well, if we were like scroll up a little bit, and if you could see like passing through to 12, so it'd be 10:12 p.m. And then when it's a.m. 2:35, we can just make it 14:35, and then could we subtract it from the like that and then just convert it into 13?
No, we can do that because 14 would actually mean that is 2:35 p.m.
But it's still passing through the 12.
Yeah, but once. Is there a wall around clock around you? Yeah. So assume it is 12 midnight.
Mm-hmm.
When 2 hours passed, there are you can see dark and stars outside. That is 2:35. But
Mm-hmm.
14:35 is a bright sun.
Oh, so it still won't work.
Yeah.
Okay.
So it's always easy if we quickly make this sketch. Suppose today is Sunday and we say that we will leave at 9:13 p.m. for the next city, and the chart says that you will reach at 3:37 a.m. the next day. So you know you crossed this 12.
Mhm.
So how long did it take? This is x and this is y. I'm finding x. 12 minus 9:13. I'm taking that carry. This is 1160 and 7:47 and 2. So we took 2 hours and 47 minutes to reach 12 and then another 3:37. So total time is 3:37 plus 2, 47. 7 and 14, 1, 4, 5, 6, 7, 8, and 5. 584. We convert it again. 6 and take 6 out. 624. So this is 6 hours and 24 minutes.
Complete journey. Um,
And we can also do that in 24-hour clock. But this was actually passing through 12. When it is not passing through 12, that is very easy. How? We started at 12. Let's say we started at 5:36 a.m. and we reached our destination at 4:13 p.m. So from 5:36 a.m., this is 12 and then that. So this is clearly 4 hours and 13 minutes. And we find this difference and add them. And if I say that we started at 5:36 a.m. and reached at 11:19 a.m. So there's no 12 involved between these two.
so we can just convert the 11 to 10 and
We
then
can, yes, 11:19 minus 5:36. So 10, that makes 6, 1, that is 79. So 3, 4, and 5, 5:43, 5 hours and 43 minutes. Gary started marathon race at 9:25 a.m. He finishes at 1:04 p.m. How long did he take? Give your answer in hours and minutes.
so this one
Please
passes
try that.
through the 12.
Yes, it is passing through 12.
3 hours and 39 minutes.
I'm getting 40. You're right. You're right. I did it with 5 actually. That was 4. So 3 are 39 minutes. Yes. Nick has a satellite TV. D recorded that. Shows time in 24-hour time. He wants to program a machine to record some programs. Write down the timer settings for starting and finishing each recording. So we just have to convert it
One
into 24.
hour. Right? 10:30 to 11:30. 1
So
hour.
this would be 22:30 and 23:30. You have to convert it into 24-hour time.
Oh, okay. And that one is AM, so nothing really changes.
So 09:15 to 10:45.
And then PM. So that's going to be 29:45.
19:45 cannot be more than 24.
Yeah.
And
21:10.
20:10. Yasmin car odometer shows distance traveled in kilometers. The odometer dial shows these two readings before and after the journey. How far did she travel? So we'll just subtract those. 97563.25
It's
minus 97263.25 is 300. The journey took 2.5 hours. What was her
oh,
average speed?
um, because time over speed 5300 120.
Yevit records three songs in onto her MP4 player. The time each of them lasts is 3 minutes 26 seconds. 3 minute 19 second and 2 minute 58 second. She leaves the gap of 2 seconds between each of the song. How long will it take to play the recordings? So this is 3 minute and 26 and then 319 and then 258 and she leaves a gap of 2 seconds. So there are two gaps. So 2 and 2. So we are adding these. 26 plus 19 plus 58 plus 2 plus 2 is 107. And on the other side, 3, 3, 6, 7, 8. I'm taking out 60 out of this 107. So when we take out 60, I'm left with 47 and take that 60 on the other side. So this is 9 minutes
47 seconds.
and 47 seconds. Try question number 5.
So at 2:30 Monday, 10th of February.
17 plus 9 is 26 minus 24 is 2:30 Monday, 7 Friday, Saturday, Sunday, Monday, 7, 8, 9, 10. Yes, 10 February, 2:30 Monday. Good. Okay. Okay. I'll share some practice questions. And yes. Hmm. Maybe this next exercise that is based on time. Anything you would like to ask?
Oh, yes. So, you know how wait, are you recording this like meeting right now? You're recording this meeting, right?
Uh, Actually, this is auto
So,
through
yeah.
the what do we say, organizer.
Oh, so
It's
you
his
don't
account.
have access to this?
Mm. You do have access to it.
I have access to it?
I think yes. Like you want the link?
Yes, because I don't know what's wrong with it, but I can't record anymore. It like shuts it off automatically.
I think you don't have to do that, but you'll have that access. Um, I don't know if I'll be able to, like, I won't be able to because I'm not the admin of this account. So
Oh,
basically, what you can do is just ask your father to send a text in the group. I think he's already added. So am I. If I go through my email address, I'll click it and I'll be able to see these recordings.
okay.
And same way you could be added.
Okay, I'll ask him to add me. He can add me, right? Or does he have to ask like the
No, the organizer can do that.
okay.
So you just like give your email address, that give access to this email address, and you'll get one email, and then there are all the links. I can show you. Um, just like this. I have this email, and I just go through it, and then I can access all the recordings. Week one, first class, and all the links are here with the passwords.
Wow. I did not know
If
about that.
if
Oh.
I share this with you, I think you won't be able to access it unless the administrator adds your email address. And I think you're already added, or maybe your father is added.
I think you can see
Yeah,
if
but that's not an issue. This could be done.
okay.
I can't do that, but the person who manages this account can do that.
Okay, I'll ask my father about it and see if he can
Is it
add.
okay if I just like I don't exactly remember what homework I shared with you.
It was also about traveling. What was his name? But I don't think it was that one. Uh, I'm trying to remember his name.
Yes.
Yes.
No. Were you able to get these answers?
Yes.
Good. Next concept is upper bound and lower bound.
Okay.
Now, basically, upper bound and lower bound are the limits.
Yes. So kind of like range, but just like the bottom and highest amounts.
Yes. Now, what happens? How do we do this? For example, someone asks me, we are standing at position A, and they ask me that how far is place B from A? And I tell them that it is about 6,000 meters, or I say it is about 6 kilometers. And they say, are you sure? Is it exact? So I may say that plus minus that to the nearest 500 meters. So when I say nearest 500 meters, that would actually mean that 6,000 plus minus 250. Like it could be 6,250, it could be 7,550, upper bound and lower bound.
So six
But
to
the
50 is
difference
the upper bound, and five hundred 5,750 is the lower bound.
is the lower bound. And the difference between two will always be 500. So upper bound and lower bound. Now, basically, if we write that as an equation, this would be 5,750 is less than equal to x is less than 6,250. Upper bound is almost in 99.9% cases not included. I'll show how. For example, we say that 8,000 correct to 1,000 or nearest 1,000. So it would be plus minus 500. Whatever we say, we add and subtract half of it. So if I would add 500, this will make it 8,500. If I'll subtract 500, that is going to make it 7,500.
And both of that would be 1,000 instead of 500.
Difference would be 1,000. Now, if I tell you write them to the nearest thousand, what will it become?
Well, that would be 8,000, and that would be 9,000. 8,500 would be 9,000.
This is 8,000 and this is 9,000. And we both know that the original value was 8,000, not 9,000.
Yes.
So that is why we write 7,500 and we write less than 9,000. So whatever it is less than, sorry, less than 8,500. Like 8,500 is not included. For example, if I say these are number of people, so I can write 8,499 and I can write 7,500 because number of people cannot be in decimals.
So in like, so that means 8,499 is actually the upper like
Upper
boundary.
bound. Now,
It's,
if I round off, this is again 8,000.
yes.
And when I round off, this is again 8,000.
Yes.
Getting point?
Mm-hmm.
Okay. So upper bound and lower bound, whatever the accuracy is given, we go half up and half down. Okay. Find the upper and lower bound of the following, taking into account the level of rounding shown in each case. 10 centimeter to nearest centimeter. So now when we're talking about 10 centimeter, nearest centimeter, this is the accuracy. So we will add and subtract half of centimeter. So see, upper bound is 10.5 and lower bound is 9.5. Then 22.5 to 1 decimal place. So when we talk about 1 decimal place, may I write 0.1,
Yes.
half of which would be 0.05. So if we add this becomes 22.55. And when I subtract 0.05, this becomes 22.45. Any objection?
No.
So whatever is the value, we add half of accuracy and we subtract half of accuracy. That says 128,000 to three significant figures. Now it is not giving me like 100 or 1000 or 500. So what should I add and subtract? It already tells me that it is to three significant figures. Now 128, 123. Now if I have to see, these are my first three significant figures, which
Yes.
obviously makes this digit the thousand. So it has been rounded to nearest 1000. So we'll add and subtract 500. If this question would have said four significant, then we would count four numbers and that would be 100 and plus minus 50.
Okay.
So in this
So
case,
we just
plus
add
5.
250, right?
In
Or
this case or the in 4SF.
well, because we're supposed to like have like a difference of a certain amount. So when we add 500 to like both the numbers, I mean, yeah, the number, it creates a difference of like 1,000 in between them.
Yes,
So when do we add like half of it? When do we add half of it?
it is always half of it. This was actually 1000. So we are adding half of it when it said
Oh,
significant
yeah.
figures. So this is that figure. And what is the value of this digit? This is unit, tens, hundreds, and thousands. So the value of this digit was 1000. So that is why we took half of it.
Oh, okay.
It is always half. Now, each of the following number is written to the nearest whole number. Find the lower and upper bound of the numbers. If it is written to the nearest whole number, that means 1
Yes.
nearest whole number and half of this. So in all
0.
of these, we add and subtract 0.5. So upper bound and lower bound. For 12, it is 11.5 and 12.5.
Okay.
For 127, it is
127.5,
and 126.5.
126.5.
Number 2. Each of the following number is correct to 1 decimal place. Write down the lower and upper bound of the numbers. It says it is already correct to 1 decimal place. It is written up to this point. So if it is written up to this point, I know the value of this place is 0.1. And what do we add and subtract? Half of it,
0.05.
0.05. So this is 2.75 and 2.65. Whenever we have to write it as inequality, we will write 2.65 less than equal to and less than 2.75 because rounding 2.75 never makes it 2.7.
I know it's supposed to be less, so it does actually equal to 2.7.
Yes. Number three, each of the number below has rounded to the nearest degree of accuracy shown in the brackets. Find the upper and lower bounds in each case. Let's do these in order. Number one. So nearest whole number. This
So we
is
have to
one.
add 0.5. Yeah.
Yes. And 132.5. Try B part.
Nearest 100. So if to add or subtract 50.
Add and subtract what?
Wait, nearest 100. So yeah, add and subtract 50.
Yes. So this is 250 and 350.
Wait, did you hear me wrong?
No, I actually skipped it. The voice
Oh,
muffled.
okay.
C part.
105, nearest 5. So it would be 2.5. So, and then we
Yeah.
subtract 2.5.
So 402.5 to 407.5. And we can always double check by subtracting both if we are getting 5 between them. 15 million to nearest million.
So that would be 500,000.
Yes, half
Add or
million.
subtract.
So 14.5 till 15.5.
Should I respond in like the answer or what we should add or subtract by?
Say that again.
Should I answer in like what we should add or subtract by or the answer?
The answers only
Okay.
for now and in exam as well.
No, no, I mean like for now.
For now, yes, the answers
Okay.
32.3, one decimal place.
Mm, 31.8 to 32.8.
31.25 to 32.35.
So we subtract.
Sorry, this is 32.25.
So for this one, we're subtracting 0.5, right?
No,
And adding subtracting.
no, no, no. This is one decimal place. This is not one. If it would have been one or unit, then 0.5. But this is already one decimal place. This is zero point 0.1 already. So plus minus 0.05.
Oh, sorry. Okay.
Okay, F
So
part.
that one's the same thing. Okay.
Yes.
So 26, 26.65 and 26.75.
Yes. G part. Answering the upper bound is always easy, like the adding.
Yeah.
So
So
write the upper bounds
0.55,
0.55 and
0.45.
0.45. H part 2 dB.
Wait, that's not the, so that would be 0.005.
Yes. So 12.345 and 12.335. Does it make sense?
Yes. because it's two decimal places.
Yeah. So difference would be 0.01 and a half, of which was 0.005 because of 2 dp. Now this is three significant figure. So we have to understand first, then second, and then third. So when we talk about the third significant figure in this
It's
case,
zero
what
point
is its
0.5.
value?
So that's the
Zero.
first, like ones place. So that'd be one. So half of that would be 0.5.
And the values will be
132.5.
lower side,
And then one 131.5.
J part. 3SF again.
So 0.0005.
So this is already 0.001 and plus minus 0.0005.
Mm-hmm.
Clear? So the upper side is going to be 0.1345 and the lower side is 0.1335. Just to be sure, I'm subtracting it. And yes. Any estimates the mass of a lion is 300 kgs. Her estimate is correct to nearest 100 kg. Between what limits does the actual mass of the lion lie?
It's plus or minus 50.
Plus minus 50. So this is
150 is the upper
250.
boundary, and then 250 is the lower.
In a race, Namatla ran 100 meters in 15.3 seconds. The distance is correct to nearest meter. That means plus minus 0.5. And the time is correct to nearest one decimal place, that is plus minus
0.05.
0.05. Write down the lower and upper bound of the actual distance and then actual time. So for distance, we have our accuracy, that is 99.5 to 100.5. And for the time, 15
15.35 to, I mean,
and 15.25.
25.
The length of the piece of thread is 4.5 meters, nearest to 10 centimeters. So when it is already given nearest to 10 centimeters, we add and subtract 5. So the actual length of the thread is L centimeters. Find the range possible values and give your answer in this form.
Oh, okay. So it'd be 9.5 as the upper boundary.
Be careful. This is meters and that is centimeters.
Oh, okay. So
So
should
this
we
is
convert
going
to
to be
meters or yeah, we
4
should. Or
centimeters.
centimeters. For this one, it would be smarter to convert the decimal, right?
Yeah, both ways is okay. Either you change this or
It
change
would
the
be
accuracy to
easy. Would it
meters.
be easy to do the decimal?
Both are okay. It
Mm.
depends on your practice. So if it is 450, we know the upper would be 455 and lower would be 445.
Yes.
Less than equal to less than and length. This is centimeters and centimeters. In other ways, we could write like this: 10 is 0.1 meters actually, and 0.05 accuracy. So this would be 4.55 and 4.45 in case of meters. Here,
Yes.
problem solving with upper and lower bounds. Okay, worked example. A is given to one decimal place, B is given to nearest whole number. Find the upper and lower bound for each of the following. Firstly, the upper bound of A and B. So this was one decimal place, that is 0.1. So we know plus minus 0.05. And for A already given, then B was nearest whole number, that means plus minus 0.5. And for B is also given. Now, when we need to know the upper bound for A plus B, so the maximum upper value would be when we use both the upper values, and the lowest would be when we use we use both the lowest values.
So highest value would be when we add the values.
Add the values. So 6.5 plus 14.5 is going to give me the highest value for A part,
And then
3.65.
lowest would be subtracting them.
Lowest is still adding them, but we use the lower values,
Oh,
3.55 and 13.5.
okay, I see.
This is 17.05. Now look at B part. A multiplied with B. So highest value is 3.65 into 14.5. 3.65 into 14.5 is 52.925, and 3.55 into 13.5 is 47.925.
So will
3
we round
point.
that? Or we just write the
No
answer
need.
for you?
The question is not telling us to.
So we don't have to. Okay.
We don't have to. If it would say that answer, give you answer to these much decimal places or significant figures, then we can do that.
Okay.
C part. Guide me through this. This is B minus A.
So
So
it'd
what
be
is going to be the
13.
highest value?
Highest would be 14.5 minus 3.65.
3.55.
Oh yeah, because it's gonna create a bigger difference.
Yes,
Okay. And the second one is 13.5 minus 3.65.
that's right. So 10.95, and this is 13.5 minus 3.65. 9.85. D part. A divided by B. For highest value, we need the numerator greatest. So 3.65 over numerator lesser
So
is
13.5,
13.5. And the other one would be
3.55 over 14.5.
over 14.5. 3.65 divided by 13.5. I'm getting large values in decimals. This is 73 by 270. Now I'm looking at these values. For A, this is two decimal place. For B, it is one decimal. So more accurate is two decimal. So I'm writing it to two decimal place depending on the data. 3.55 divided by 14.5 is 0.24 if I round it. This is 5. And the first one was still 0. So three decimal places. This is the answer. E part.
So sorry, A would be 3.65 and then B would be 14.5. Wait, no, because it still has to be the same aim. Because I was thinking of doing 13.5 for the bottom, but it's not possible, so.
Okay. In B, there's no doubt that we'll take the upper end, right?
Yes.
13.5, and let's quickly check with 3.65. I'm taking 3.65 and getting 4.97. And checking with 5.5 is 5.08. So with 14.5 plus 3.55 is giving me the higher value. That is 5.08, rounded to 3 decimal places.
Okay.
And then for the lower end, lowest value for B was
13.5 plus 3.65 over 3.65.
lower end, higher end, 13.5, 3.65 over 3.65 is 4.699, upper end and lower end. Okay. Exercise 13.5 is you are given that A is equals to this, B is equals to this, C is equals to this, D is equal to this. Calculate the upper and lower bound for each of the following to three significant figures. Before we do that, let's write the accuracies for every number first. So when it says 1 decimal place, that means it's 0.1, and that is plus minus 0.05.
Yes.
Again, 1 decimal plus minus 0.05. Three significant. In this
So that
case,
would
the
be 0.5,
0.5 plus minus 0.5. And the last one is plus minus
0.005.
0.005. Correct. So calculate the upper and lower bound for each of the figures. So straight away for a square, we use the added values. Let me use this base.
5.65 would be the upper boundary,
That's right. This was 13.
and 5.55 would be lower.
Okay, so for a square, 5.65 squared and 5.55 squared is going to be upper and lower bound. B part is B cube, 24.15 cube and 23.95. 24.1 minus 0.05 is 24.05. Upper and lower bound. I think all those in the numerator are easy to understand. The ones which are divided will be the one we need to focus on.
Sorry,
C part says,
so the ones,
I said the ones which are like clearly in the numerator only are
mm-hmm,
not an issue. Like a square plus b square or higher, and we use both the higher values.
mm-hmm.
When we are doing for E part, let's jump to that. So for E part, which says C divided by B square. Now for upper bound, I need higher value of C, which is 145.5, lower value of B, which is 24.05 squared. And we have to answer to three significant figures. So this is 0.52. And lower bound is lower value for C, 144.5 over higher value for B, 24.15 squared. Zero point 0.248 up to three significant figures.
Okay.
Can you try F part? Are the values readable?
Yes.
Let me know the answers of upper bound and lower bound. Use your calculator. I'm getting these two values.
Oh, I'm not finished yet, sorry. Okay.
Are you getting the same answers?
Uh, I'm not sure yet. I'll just be one more second. Like maybe two more. So for the upper boundary, I got 2.7.
2.7?
Yeah, because it's 2.3306 probably like
I'm getting
2.7, 2.82. So for your A and B, you multiplied 5.65 and 24.15, right? Sorry?
Yes, I did that.
And then for your C and D, you multiplied
6.5 into 24.15. And C and D
144.5 into 0.3455.
0.335.
I think that's where I messed up.
In the last value.
Yeah, I think so.
And for the lower bound, 5.55 into 24.05 divided by 145.5 into 0.345. These were the values for lower bound.
Okay.
Okay, CG part is C over A minus B over D. So I'm going for upper bound first. To get higher value, I am using higher value C,
And
which
then
is
lower
1,
value B.
5. And for A, the lower value is 5.55 minus. What did you say about B?
It had to be the lower value for both of them, right?
Only for B. Lower value for B is 24.05 and higher value for D 0.345. Why so? Higher value for this to make this overall fraction small. So we get the
Oh,
final answer
yeah.
larger number.
Okay, and then when we subtract both of them, that's still gonna create like a bigger difference. So it's gonna be the higher value.
Yes. So this is 0.345
Mhm.
and overall I'm getting a negative number. Hmm. Maybe this would be the lower bound because it is a negative sign. Let's do for both and then finally decide. So minus 43.4939 approximately equal to minus 43.5. And let's do the same for
But that's
the,
without changing it, right?
yeah, that would change because of this negative sign.
No, no,
This
I
is one.
mean without like making the other adjustment.
Yes.
Mm.
5.45, 24.15 and 0.335. 445 and 65 24.15 0.335 and that's correct minus 46.514 and up to three significant figures is this. So upper bound and lower bound. Any confusion?
Mm, not for the upper bound or the so for the lower bound we used both lower values. So
Not always.
14.5.
See, for lower bound I used lesser value for C and higher value for A.
Mm-hmm.
To get this overall fraction lesser, then we are subtracting. So if it is lesser, this overall number should be higher to get a lesser difference. So higher value for B and lower value for D.
Wait, but 5.45, isn't 5.55 the higher value?
Yeah, we did that on the other side. I'm getting overall lower bound. See this. So when we use lower over here and higher over here, overall, what do we get? We get a lower end.
Yes.
Do you agree?
Yes.
Then we are subtracting something. How will we get an overall lower value when this end is higher end?
That's how the
So
lower
how do we end at higher end? We use the upper higher and the denominators lower to get the overall higher, and lower minus higher difference, we're getting a lower difference.
I know, but and you said lower and higher, so 5.45 is the higher one for A, right?
5 point.
Because isn't
Yes.
5.55?
Uh, that's a mistake. This is 5.65.
Oh,
Writing.
okay.
True, and let me check. I just wrote that, but I did it correct in calculator. 5.65 was the higher end.
Okay.
5.65, yes.
And then for upper, it's higher on top, lower on bottom, and the second one is lower on top, higher on bottom. For upper boundary.
Yes. Okay, let's try each part. And before we solve, this is A divided by D and divided by C over B. So we can simplify it. A over D multiply by B over
Yes.
C. So basically, this is exactly F part.
Just A and B have to be the highest, and D and
Com-
C.
Compare it with F part first.
Yeah, it is. I mean, it is the same lineup.
Yes. So for the upper bound, A is higher, B is higher, C lower, D lower. And for the lower bound, A is lower, B is lower, C is higher, and D is higher.
Fine.
I'm coming on I part. DC plus square root A over B. So upper bound DC plus square root A over B. Now let's decide what do we use. For upper bound, D is higher or lower?
So for D, we would use the higher. Yeah, we would use the
Correct.
higher, so to add them
But
together.
B,
And C is higher as well.
correct. A and B.
A is higher, and then B is lower.
That's right. So this will give us upper bound. Now lower bound. DC plus A over B square root. So D would be
Lower, C would be lower, A would be lower, and B would be higher.
correct. J part is DC minus square root A over B.
So still, D would be higher, and C would be higher.
Higher, higher.
Yes. And then
And
A would be um, lower, and then B would be higher.
Very nice. And for lower bound, D, C, A will be square root.
So D would be higher, C would be higher.
Lower, lower, the same lower because we are calculating lower bound.
Oh, so both would be lower. D and C would be lower, and then A would be higher, and then B would be lower.
Correct. So this will give us the lower bound. Jonathan and Priya went to fit a new washing machine in their kitchen. The width of the washing machine was 79 centimeters, correct to nearest centimeter. So I'm just writing this 79 plus minus 0.5. To fit the machine, they have to make a space by removing cabinets. They want the space to be as small as possible. So what is the smallest space into which the machine can fit?
So it has to be 79 points minus 0.5, right?
Right. So 78.5 is the smallest.
Yes.
What is the largest space they might need? So we add the equation
79.5.
79 point.
Yes.
Now in real life examples, for example, you have a cabinet
Mm-hmm.
and you want to add a shelf. So
A
for
shelf?
example, we have a shelf.
Yeah.
Already have these cabinets and we wish to add a shelf right here. So that also depends which type of material you are talking about if you want to add a glass shelf. Now you have these lengths. It is 78.5 and 79.5 according to the accuracy. Now a glass shelf cannot go over the exact length because glass will not fit in. It is brittle. If you'll force it, it will break. If that's a wood or plastic, you can always force that in. In other ways, if we are talking about the lower end, if I can show you closely, you can always put these clips and glass can
Oh, to make it stronger.
raised over it by its weight, like these clips.
Mm-hmm.
There's a screw inside, and even if the glass is smaller in length, it can just rest on these clips. So in that case too, we know that we can go with the lower end. Question number 3. 12 kg of sugar are removed from a container holding 50 kg. Measurement is correct to the nearest kilogram. Find the lower and upper bounds of the mass of sugar left in the container.
Oh, so just 15 minus 12, and then we find the upper and lower bounds. So we
Before
have
we
30.
subtract, we need to select the higher and lower values. Each measurement is correct to nearest kilogram. So we know we are talking about 50 plus minus 0.5, and we're talking about 12 plus minus 0.5.
Can't we just do that after we subtract them? Or we have to do it before?
We have to do it before because you cannot say that the mass of the container was 50. It would be either 50.5 or it would be 49.5. And if you are subtracting it first and then adjusting the limits, then you will have to deal with both the limits. In this case, both are 0.5, 0.5. So we'll either add 1 or we'll either subtract 1. But in some cases, like in question 1, which we just did, we are
Mm-hmm.
sometimes using the higher end and we are sometimes using the lower end.
Oh, so to
So
okay.
12 kg of sugar are removed from the container. Each measurement is correct to nearest kilometer. Find the lower and upper bound of the mass of sugar left in the container. So This would be higher mass left in the container when we take 50.5 and when we remove 11.5. Getting it? So we're using higher and lower. We are using combination of both. So this is 39. If you just subtract 50 and 12, that is 38. And then you would have to add both the accuracies to get 39. That will become more complicated.
So when there's two values that it's giving us and it wants us to find the lower and upper bounds, because I'm doing it for myself for like the exam and everything, because it won't be saying which section it's supposed to do, and it's not gonna give us a total like explanation on what we have to do. So when it gives us two values and asks us to find the lower and upper bounds, we first find the lower and upper bounds for each one, right?
Yes.
And then we do it like that. Okay.
This is the greater difference,
Mm-hmm.
and lesser difference is 49.5 and 12.5.
Yes.
It also depends on the statement because he was interested about the mass which is left behind. He's not interested about the mass which is taken out.
Oh, so even if it's taken out, we still have to find it individually, right?
In
Oh
case
no,
when
no,
it
we
is
don't.
taken out,
No, no, no.
the
We
answer
just
is only 11.5 and 12.5.
yeah.
So that's 39 kgs and 37 kgs.
Yes.
Try question number 4.
Mhm. So for 3.61, the highest value is 3.615, and the lowest is 3.605. And then for 2.57, the highest value is 2.575, and the lowest is 2.565. Yes. Each correct
For
answer
both
will
of these.
be significantly
So write
different.
down the upper and lower dimensions correct. Find the upper and lower bound for the area of the rectangle.
Oh,
So area is just the product of these two.
yes. So the
We just
highest
multiply.
one, yeah. So the highest one would be 3.615 and then 2.575, right? For the
Yes,
upper bound. And the lower bound would be 3.605 times 2.565.
565. And C part says write down the upper and lower bound of the area. What is this? Find the upper and lower bound of the area of rectangle. Done. Write down the upper and lower bound of the area. Correct to three significant figures.
Doesn't mean the answer.
Yeah, but
Oh, wait, I think B is you just multiply 3.61 and 2.57 and then find the upper and lower values of it. And then C is the one that we just did.
right. Fifth one. The mean radius of Earth is 6378 kilometers to the nearest kilometer. Assume that the Earth is a sphere. Find the upper and lower bound for the surface area of Earth in kilometer squares. The mean radius of the Earth is this 2 nearest kilometers. So nearest kilometer is plus minus 0.5
5.
only. So surface area of Earth. For surface area of Earth, if it is a sphere, so surface area is 4 pi r square. So 4 into pi and radius is 6378.5. 6378.5 squared. So this is upper,
Mm-hmm.
and lower is 4 pi 6377.5 squared. Upper bound and lower bound. B part says volume. So 4 by 3 pi r cube. So basically we are only interested in the upper and lower value of radius. So 6378.5 cube and 4 by 3 pi 6377.5 cubed is upper bound and lower bound. Question number 6. I just remembered an interesting question. I hope I rephrase it correctly. You are given with 1 meter length of ribbon, correct, to 10 centimeters. And we cut 10 lengths of 5 centimeter, correct, to 1 centimeter.
So are these two questions or one question?
One question. One question. These are the statements. Information is given. So what do we have to find?
Well, we can first turn the 1 meter to 100 centimeters.
Yeah, we'll definitely convert them. Find the
And find
length
the
remain
length.
and what we have to find the maximum and the minimum possible lengths remaining.
Well, doesn't mean correct to 10 centimeters, so subtract until we get to 10 centimeters.
When it is correct to 10 centimeter, what do we add and subtract?
5.
5.
Mm-hmm.
Is correct to 1 centimeter, what do we add and subtract?
0.5.
0.5. Now we have to find the length remaining, maximum length and minimum length.
The 10 lengths of 5 centimeter thing would be 0 yeah, 0.5. Each length would be 0.5. So we got 10 lengths off of 5 centimeters.
0.5 what?
Each length, like each 10th length would be 0.5.
We cut 10 lengths. You see, there's 1 meter length of ribbon. So this
Yeah.
is 1 length of ribbon. Now what are we doing? We
Oh,
cut
we cut
10
10
lengths.
lengths of 5 centimeters. So 5, 10, 15. Oh, I see. 50 centimeters then.
So this is left.
Yeah, so 50 centimeters.
The maximum and minimum length, which is left behind.
Mm-hmm. So if it's 100 centimeters length of ribbon, it's still going to be 50 left over. So the maximum left over would be 50.5, but
Don't rush through the question. There's accuracy to both of these, full length and those cuts.
10 lengths of 5 centimeters is 50 centimeters.
Do you agree that for maximum length, we will write 105 minus 10 lengths of 4.5?
Yes. Yes.
So we're left with 105 minus 10 into 4.5, which is 60 centimeters is left. So we actually assume that the ribbon was 105 centimeters and we are cutting 4.5 centimeters. So maximum length is left. Then
And
for the
the
minimum,
minimum would be 95 minus 10 times 5.5. So that's what it's asking us. I see. I was thinking of it like very differently, like 50, and I left over 50, and I was trying to correct the 50 into 0.5, but no.
is always easy if we add and subtract the accuracies first and then use those values. Like don't go with 105. First use the corrected values and then find the upper and lower bound.
Okay.
One more question I can remember that was regarding area. So this is the rectangle and length is given 20 centimeters plus minus 0.5. Now in this case already plus minus is given, upper lower is given.
Mm-hmm.
Breadth is unknown and area is given as 30 centimeters square plus minus 0.5. So we need to find B max and B minimum. Let's say to one decimal place. How will we do that?
We're going to start, so 20.5. I see. Wait, what do you mean to one decimal place?
Like the final answer.
Oh, finally, okay.
Like make it two decimal place for ease. So area is given, length is given, breadth is unknown. So we need to find the maximum and minimum breadth of this rectangle.
Well, 1.5 plus 0.05 plus or minus
Basically, area
0.05.
is equals to length into breadth.
Yes.
Breadth is area by length. So if we are solving for maximum, what is the value of area?
Area is 30.
30.5.
Yes.
And
And
value
then
for length is
length would be 19.5.
19.5. This will give me the maximum breadth. 30.5 by 19.5 is giving me 1.56 decimal places. And breadth minimum would give 20.5.
So 29.5 and then 20.5.
1.44 decimal places. Centimeters, centimeters. Okay. Question number 6. A cup holds 200 ml to the nearest ml. So plus minus
0.
0.5. And a large container holds 86 liters to the nearest liter.
Still 0.
Plus minus 0.5. But be careful, this is milliliters and that is liters.
Yes.
What is the largest possible number of cupfuls of water needed to fill the container? So largest number of cups is going to be 86.5 divided by 0.20, 0.5. Do you agree? Largest number of cups will be given by this formula, and smallest number of cups would be given by these values. 85.5 divided by
What does it mean
0.
by the largest possible number of cupfuls? Water needs
You're
fill.
filling those 200 ml cups and
Mm-hmm.
pouring it in the large container.
Oh, how many
Like
would fill it? Is that oh yes. How many would fill so if we keep on pouring it?
yes,
Okay. Why so we're dividing it with each
to
other.
get the number of cups. Like if you consider we are filling a swimming pool using tubs, so volume of swimming pool divided by volume of tub will give us number of tubs.
Oh, okay. Then yes, I do agree.
So this is 431.4 and 200 minus zero point 0.5 was this is actually 199.5. 0.1995. So 85.5 divided by 199.5 gives me 428.6. Largest number of cupfuls of water needed to fill the container. What is the smallest? So these are the values. So we can say approximately equal to 431 and approximately equal to 429 cups. Question number 7. A straight road slopes steadily upwards if the road raises 8 meters to the nearest meter plus minus 0.5 over a horizontal distance of 120 meter given to nearest 10 meters plus minus 5. What is the maximum possible gradient of the road? What is the minimum possible gradient? Can you do that?
Yes. Wait, the formula for gradient was it was the highest and then the lowest.
Gradient was rise over run.
Yes, so that's the oh okay, okay. Sorry. 0.5 over. So it would be 8.5 over 115
Right?
as the maximum possible. And then
That,
the lowest would be
and what is the value?
oh
up to 3 significant figures.
So it'll be 0.0739, right?
0.0729. Very good.
Yes. And then
And lower bound.
so it would be 0.06.
0.06. That's right. So with 7.5 and 125. 0.06. Let's try this question number 9. The angle in triangle are x degrees, 38.4, 1 decimal place, 78.1, 1 decimal place. Calculate the upper and lower bound for x. So if I have to calculate x, I know that it would be 180 minus the other two angles. So
Added
if
to.
I'm taking the higher values of the other values, so I'll get the lower bound of x. So it is 38.45
And then 78.15.
and 78.15. And for the upper bound, we take the lower ends, so 38.35 and 78.05. 180 minus 38.45, 78.15, and we get 63.4. And 180 minus 38.35 minus 78.05 is 63.6. Any confusion?
No.
Okay, I'll share the remaining questions
Okay.
as practice questions along with answers. And what do we have next? Okay, conversion graphs. That's an easy topic. One and many. Hopefully, we'll be able to complete this chapter max by tomorrow.
Okay.
Anything you would like to ask?
Mm, no.
Okay. Sharing these remaining questions. We'll continue with the next topic and I'll share this via email. Conversion graphs. What do you know about conversion graphs?
Well, I know that they convert between like different maybe currencies, like different measure like units, measurements.
And what do you think is the difference between the conversion graph or um, given units? For example, if I say that 1 USD is equals to 270 PKR. So $1 is 270 Pakistani rupees. So this is conversion rate at current time. So obviously, if I have PKR on x-axis and USDs on y-axis, so I would know that is 0 rupees would represent $0, but 270 would represent 1 USD. So do you find any difference in this given data or the conversion graph?
Graph can show more values, but
It
it's still
can
the
show more
same.
values. So basically, it is just the reading time. So we may see that what does 1.5 USD look like? So I'll just go to the graph and read the value. And we also have limits in graphs. For example, if this graph is already drawn for 600 rupees, so I cannot go beyond this using the same graph. But on the other side, I can do it for 6 million as well and put an X over there, right?
Yes.
So basically, they're one and the same thing and depends on our use. So an example, 8 kilometers is approximately equal to 5 miles if you travel no distance in kilometers. Then you also travel no distance in miles. The 2 points of reference enable you to draw the graph for converting between the two measurements, just like we did. We used 1 USD equals to 270 PKR. So when we do so, we now know that 8 kilometers is equal to 5 miles. So on the graph, we read that point 8 and 5. Let me change this color. And this is 8 and 5. And then we can extrapolate the graph. If the line is extended far enough, you can read higher values. Notice, for example, that the line now passes through the point with coordinates x25 and y40. That means 25 miles is equals to 40 kilometers. So check for yourself. Now, the important part in this concept would be reading the values from the graph. We should read them accurately. So check yourself that 10 miles is roughly 16 kilometers.
Yes. Because it would
Is
be
this
10, 12, 14, and then 16.
Yeah. So reading the value correctly is the main task. 12 miles is roughly 19. Now, when we talk about 12 in this case, on the x-axis, there are one box is equal to 1 unit each. So it is not difficult to read 12 on x-axis. I just have to reach the 12th mark. So this is 12 miles. So we go vertically upwards and then horizontally to left hand side. Now this is, I'm not very sure what this value is at all times because
But
one
since
box is,
they're like twos, then since it's kind of like in the middle of the twos, then
yes.
if I
So
say
it may not exactly intersect the line. It may be like 47% of that line. So rough estimations are acceptable. 20 kilometers is roughly 12.5. Now we are moving from y-axis to x. So we draw a horizontal line from 20 and then we move down vertical where it intersects the line and we read the values and it is roughly 12.5 miles. Whereas unitary method would give you exact values. Okay, the graph shows the relationship between temperature in degrees Celsius and degree Fahrenheit. Use the graph to convert 60 degrees Celsius to Fahrenheit. Is the graph readable?
yes.
So 60 degrees. Degrees are on x-axis and Fahrenheit's on y-axis. So what value do you think it is giving us?
It's giving us 100 and oh, wait, no. Yeah, 180. No, no.
You
Because
want me to draw the line?
no, it's okay. I know 60 goes up to like, just under the line of 150, but I'm trying to figure out which the value of that would be.
It intersects here, and I guess this is the point. So what value does this represent?
40, 140.
Very good. 140. So we know that one box on left-hand side or y-axis is actually 10, and one box on x-axis is 4 units. Next, 16 degrees to Fahrenheit.
would be 60.
Now 16 is on x-axis. We
Mhm.
need the value on y-axis. So what did you say?
60.
Good. Now 0 Fahrenheit to degree Celsius.
0.
Not necessary.
Oh, wait, this one doesn't do that.
And this is temperature.
30. 30?
0 is on y-axis, right? So 0 on y-axis is right here. And
Mm-hmm.
when I go towards left-hand side, this is less than 20. So
Negative.
cannot be 30. Yes. So cannot be 20.
Oh,
So just look closely. It is a little to the left. So 4 units, this should be 4, 8, 12, 16, and more than 16. May I write minus 17?
but so we find it by looking upwards, right? Like how many lines is upwards, but for 10, 20, isn't it 20?
The 20 should be at the fifth mark of the box.
No, I
See
mean,
this?
yes.
20 should be at the fifth mark.
I
So
mean
this
for
is definitely
0,
not.
it should be 20 Fahrenheit, right?
That's what I'm saying. This. No, we started with 0 Fahrenheit.
Which one is 0? Is the one you draw like the blue one is 0?
Yeah, on the y-axis.
Okay.
We're looking at 0 of y-axis. So this point, and we move horizontal and it intersects right here, which is a little to the left of fourth box.
Mm-hmm.
So each small box represented 4 units, that would be 16, and a little more than that is minus 17. 100 Fahrenheit to degree Celsius.
Oh, it's not exact either. So 38.
Very nice. So this seems like in between that box. So it is 38 degrees Celsius. Number 2, the graph is a conversion graph for kilometers and pounds. Sorry, kilograms and pounds. Use the graph to answer the question below. What does one small square on horizontal axis represent? Don't put too much strain on your eyes. It is either 5 boxes or 10 boxes. Always.
I can see the mic of the 5. So that
Yeah.
was 20 since it's in the middle of them.
No, it's just asking this value of one small box. What does one small square on horizontal axis represent? I can see that 40, which is exactly on the 10th box. So one small box would represent 4.
Oh, because we divided.
Yeah,
I think
you
I
see?
also miscounted it. I think I also miscounted it because I was counting how many boxes there were, and I got 11. So I think I was also miscounting it.
Yeah, but it will always be 5 or 10.
Okay.
So in 1 centimeter, in this case, these are 5 boxes. And we can see 5, 5, 10. 10 boxes are representing 40. So one small box would represent 4. So it represents 4 pounds. What does one small square on the vertical axis represent?
Mm. 4 as well?
4, yes, and 4 kilograms. Change 80 pounds to kilograms.
36?
Very nice. 36 kg. The minimum mass to qualify as an amateur lightweight box is 57 kgs. What is this in pounds? Now we have to reach 57 first. Let me zoom in. So one small box on either side was 4. So 4, this is 44, 48, 52, 56.
So somewhere like very close to the 56. 130?
Look at this. On y-axis, we know that one box is 4 units. So this last box, second last box is 56. For 57, I should assume 4 small parts of that one box. Now I'm coming horizontally at this 56 mark because I can see that clearly. So when I'm moving towards right hand side and I know that I have to answer for 57, now I'll be moving up a little and maybe it intersects at this point. So this is 120 and the next line is 124. It is something more than 124 and definitely something less than 128 because 2 boxes are 4 units. So a little more than that is 125. And when I use calculator, I'm getting 126.6. E part, which of the following conversions are incorrect? What should they be? Okay, firstly, 30 kg, 66 pounds. Let's see. 30 kgs, 66 pounds.
Could you scroll in just a little bit more?
Yes.
Okay, thank you. 64?
The question is 30 kgs is 66 pounds. First, we have to see if that is wrong, then we will give the correct answer.
Okay, so it's
So
wrong.
30 kgs is on y-axis,
Mm-hmm.
exactly between 20 and 40. This should be the point. And I'm slowly reaching on right hand side and I'm intersecting at this point between these two. Now see, this is 40, this is 20, this should be 60, and I know one small box is 4,
So 65, 60, 66.
66. So that's correct.
So it's true.
Yeah. So are you getting it? Everything is a reading of the graph. This topic is just reading the graphs correctly. Second says 18 pounds equals 40 kg.
No.
This is clearly wrong.
Do we have
Let
to get
me,
the right answer?
yeah, now we have to correct it. So 18 pounds is equals to how many kgs?
36.
18 pounds.
18 or AD?
18,
18.
18, 1 8, 1 8.
It's at 8.
8 would 60 pound, 37 kg. 60 pound, 37 kg. Is it correct?
No,
No. So how many kgs should it be?
28.
Correct. And the last one, 20 pounds, 9 kgs.
I mean, it looks like it's on the 8, but it's a bit above, so it could, yeah, I think it is correct.
It is correct. Good. Number three, the graph shows the conversion between UK pounds and US dollars as shown on the particular website in February 2011. Use the graph to convert 25 pounds to dollars.
$16?
25 pounds to dollars. Dollars are actually more than 25. Pound is on y-axis. One small box on y-axis is 4 pounds, right?
Mhm.
One small box on x-axis is $4. Now, when I have to see about 25, so one more box above that is 24. So slightly above that, when we move horizontally, I see that maybe it intersects at 40.
So is it 40?
$40. Now 52 pounds. This is the 13th box. How did I reach that point? 52 pounds. I did 52 by 4. I'm getting 13. So 13 boxes will represent 52.
Is it 84?
That's 84. Yes. $80 to pounds.
It's around the middle of
Right.
48, 52. So 50?
50. $65 to pounds.
42?
42. I was expecting 41. We may have a difference. Slight one. Okay. The cooking time in minutes for a joint of meat in kilograms can be calculated by multiplying the mass of the joint by 40 and then adding 30. The graph shows cooking time for different masses of meat. Before we move on to the graph, we can actually write the equation for this. Cooking time in minutes for joint in kgs can be calculated by multiplying the mass with by 40. So whatever the mass is, we are doing this, right? And then adding 30. So basically this is y-intercept. So it's giving me cooking time equals 40 into mass plus 30. So
So
when I move, sorry, say it,
never mind. So time equals to 40 and plus 30, right?
40 and plus 30. Now look at this red line. Does it look like this? 30 is the y-intercept and 40 is the gradient. Because for every 1 kg, it increases 40. For 2 kgs, what would it be? 2 into 40 plus 30. 3 kgs would be 3 into 40 plus 30, and so on. Use the graph to answer the following questions. If a joint of this meat has mass 3.4, now what am I doing?
Just
What are we doing?
like,
We have read the equations. We know how to make subject. So basically, I have to answer from the graph, but I can quickly make an estimate. I know this is 3.4 kgs. So 40 multiplied by 3.4 plus 30, it is 166. So my answer should be close to 166. Now I'm coming on the graph. So when I look at the graph, 3.4 is this box. Do we agree?
166? I got
Uh,
136.
166, yes.
I got 136 when I did, like, when I times.
You forgot to add 30,
Wait.
then adding 30. Additional information
Oh,
you should add.
yeah. And then we have the 30. So, yes, 166. And
And
then,
from the graph,
do we
this,
have to look at it from the graph or can we just write
no,
it
no,
down?
no. You have to answer it from the graph. This is something that we already know. This is additional help. Malam is helping herself because she studied this.
Okay.
So this is question of graph, and actually what the examiner should see is we will use a rule, scale and pencil and draw this line and show this point of intersection and then draw a horizontal line and then read this value. Now this was 50 divided by 5, one small box is 10. So this is 150, then this is 160. And that if that is exactly between the two boxes, I will write 165 despite knowing that it is 166. Are you getting my point?
Yes. So we still have to use a graph just
We
because
have to use.
that's the purpose of this. Okay. And it's also a
Now,
question.
now how will we write 166? Because we know that actual answer is 166. We will draw the line very carefully. So it is slightly above that half box because we already know the answer. We reversed calculated it from the equation.
So 166. But it would be still be okay if we wrote 165, right?
Yes, absolutely correct. If a joint of meat is to be cooked in 220 minutes, now before I look at the graph, I'm taking out those 30. So 220 divided minus 30, I'm left with 190 and divided by 40, the mass should be 4.75. Now let's find 220. This is 220. Do you agree?
Yes.
Let me change this color. And now we move horizontally. We use our scale and pencil and we draw this line and intersects at this point and here. So if I see this, this is 4, 1, 2, 3, 4, 5, 6. This is 4.6. And at the end is 4.8. Now my calculator gives me 4.75. We have to be careful because our eyes are not that accurate that they can read these boxes up to two decimal places. What most can I do? If I'm talking about this one box, let me enlarge it. This right here is 4.6. The other end is 4.8. So if we feel that it is exactly in between, I can write 4.7. And
Oh,
if it is exactly in between the second half, getting the point?
yes. Could we also write 4.8 because like when we round 4.75?
4.8 is exactly the other boundary. So
Okay.
we will not do that. So when I'm looking at this point, this is just the last quarter. So I can write 4.75 because in this case, it is giving me that value. C part. By calculating the mass of piece of meat, it only takes 25 minutes to cook. Explain carefully why it is not possible to use this graph. Okay, try that.
Could you zoom in just a little bit?
Move what?
Zoom in.
Zoom in. Okay. I'll zoom in. Just have a look at C part. So if it is taking 25 minutes, we cannot use this graph. Why?
Because it doesn't go down to that.
It doesn't go down to that point. It is telling you that even if it is 0 kgs, it would take 30 minutes. Question number 5. You are told that Mount Everest is approximately 29,000 feet high and that this measurement is approximately 8850 meters. Draw a conversion graph for feet and meters on graph paper. Let's try that. I think I'll quickly draw a sketch and then use that software to draw the accurate graph. So we know that Mount Everest is approximately 29,000 feet high. So I'm using feet on x-axis and meters on y-axis. Definitely we will select our values. And let's say 29,000 and I'm expecting that we have 10 boxes. So divided by 10 is 1, 2, 3. I'm making one of the boxes 3,000 or 5,000. 30 divided by 5 is 6. So 5,000, 10, 15, 20, 25, 30. So 29,000 against 8,000. So let this be 1,000. 2, 3, 4, 5, 6, 7, and 8.
Should it be up
And
to,
then,
because
sorry,
should it be up to 9?
up to 9, yes. Or maybe 10, no issues. So 29,000 is against 8,000 something. So I'll mark this point and then we'll draw this line. So draw the conversion graph of feet and meters on the graph paper. You are now told that Mount Snowdon is approximately 1085 meters high. So 1085. This is 1000 right there. 85 would be slightly. Now, if we would have been doing it on the graph paper, I can read the boxes. Let's say these are 10 small boxes. So 1000 divided by 10, one small box is representing 100. So 85 is slightly one box, and we'll read it from the y-axis where it intersects. This is definitely not the correct answer because x's are not uniform.
So should we use like the proportions?
No, it would be easy to read on the graph paper. This is just a rough sketch.
Double check.
And yes, we will definitely use those proportions. Like we can write 8,850 and 29,000. And I need to answer this. So this is 29,000 times 1085 divided by 8,850. And this is giving me 3,555 feet. A tunnel in French Alp is 3,400 feet. Approximately what is the length in meters? So obviously we read from the x-axis where 3,400 would intersect and we convert them into meters. Is the concept clear?
Yes.
Okay. Mount Rubakumar on the planet Ithorides is 1,800 feet high. This measurement is equivalent to 3,450 splodges. Draw the conversion graph of this on this. So again, on x-axis, we take one of the units. Let's say SQ is on x-axis and SP is on y-axis. So 1,800 is equivalent to 34, wherever it would be. We'll draw that line and then solve the remaining questions. Can you please take this screenshot of question 5 and 6 and try any one of those on a proper graph paper? Will that be possible?
Yes.
Well,
Okay. Wait,
sometimes very easy to think, but we may experience a different problem and you may need to ask something.
like for example, I think C for 16. Okay.
Okay. Now, money. Just like we did an example for dollars and PKRs. Now, whenever we face the question for like this length, feet and meters, you see there's no timeline given.
Mm-hmm.
But when we did this pounds to dollars, you see it is given that in 2011. Because this is something that would disturb a student solving the exam, because there was a time when 1 pound was 122 rupees and today it is more than 250. So if that keeps on changing, mentally you would get disturbed when you find that answer because you know that 1 Canadian dollars equals this much US dollars. That is for today. So whenever we are solving money questions, timeline would be given. So it says the exchange rate, and particularly they've excluded that part that was buying and selling. Do you understand what buying and selling is?
Oh, how much like you're going to get profit from selling something after you buy it?
Buying and selling of currency. Let me say again, I'm talking about Pakistani rupees and dollars. Suppose I go at an exchange and I ask them to give me $1 and I have to pay 270.8 for $1. And if I'm giving them back that $1, I'm selling it and they're buying it. Basically, the exchange is always at a profit. The individual is at a loss. So when I give that dollar back, they do not pay me 270.8, they're paying me 268.9 maybe. So this is buying and selling. For example, you plan your summers to visit Europe. So you have some Canadian dollars, you exchange them to euros before you travel. So you see, Canadian dollars to euros. Now you have those euros. You went on your trip, you saved some of the money, you came back, and then you changed it again to Canadian dollars. And luckily, when you changed it back, the price was more and you got more dollars back. That is possible. But on spot, on spot selling and buying will give a loss to the individual.
I know that happens for selling like other like products and everything, but why does it happen in during like currencies? Is it supposed to be like accurate each time?
No, that's the hard reality when life hits you.
Okay.
That's the hard reality. For example, if you buy a gold piece of gold,
Yeah.
you are standing at the shop, you buy a piece of gold, you just paid them $1,000 and you bought that piece. And you give them back instantly, they'll not pay you 1,000. They will tell you the current rate for gold is this.
So it's
They'll
always
say it is fluctuating.
okay. That
Suppose we have one shop, they have a very good repute. It is possible. It is possible that they'll pay you back 1,000. But 99.9% of the time, the individual is at a loss. Other way around, you bought that gold, you went back after 1 week because you checked that the prices are increasing.
hmm.
So this is possible that you'll give them the piece back and they'll pay you 110. You paid them 1,000 and they pay you 1,010. So that is product and money. But money with money is the current rate. In your free time today, just see that. Um, l- let me let me show you. You see this graph?
Hmm.
One PKR currently is 0.0036 USDs. And you see this graph, this is the fluctuation. The price keeps on changing. But when we talk about the instant, the right moment, let's say there is no delta T, no time is changing. Even then, the individual is at a loss. If you're standing at the exchange and you pay them $1,000 to get euros, and now you pay them the euros back to get your $1,000, no, you'll be at a loss. So buying price is different and selling price is different. And yes, there's nothing hidden. It is displayed in front of you that if you buy, this is the price. If you sell, this is the price.
So the
No
rates.
hidden charges. So we actually know what we're doing. No one is cheating us. And in the questions, whatever it would be given, it will be written, it will not change.
Okay.
So foreign currencies and an example, dollars 100 cents, yen 100 cent, pounds 100 pennies, euros is 100 cents again, and rupees is 100 paisa. Worked example. Convert 50 pounds into Botswana Pola, given that 1 pound is equal to 9.83 polas. So unitary method, simple unitary method. So 1 pound is 9.83, 50 would be 9.83 into 50. And we get that answer. Second example, convert 803 pesos into British pound. And rate is given that at that instant, 1 pound is 146 pesos. So we just do that. I feel comfortable writing it this way. Pound, let me write it here. Pound ratio pesos. This is 1 ratio 146. So when it is 803, that would be x. So cross multiply and we'll get our answer.
Yes.
Try question number 1. Find the cost of 8 apples at 50 cents each, 3 oranges at 35 cents each, and 5 kg of banana at dollar. Okay, this is not conversion. This is a simple question. Still, can you do that? Do you have your calculator?
Uh, no, can I quickly grab it? Sorry.
Yeah, you'll need that.
Okay, I got it.
The total cost.
No, I have 400 and I have 105. And then I also have 13.45, but that's like dollars. 400.
Whenever we calculate, we always convert them into same unit first. See question number 1.
So
May
yes.
I write 8 times 0.5?
Sorry, 8 times. Well, yes, because since you divided by 100.
Yes, plus 3 times 0.35 plus 5 times 2.69, and I'm getting $18.5.
As a total. Okay.
Question number 2. How much would you pay for 240 textbooks at 15.4 each, 100 pen at 125 each, and 30 dozen erasers at 95 cent each.
3,849.
We're getting different answers. 214 to 15.4, right?
Mm-hmm.
And then I have 100 into 1.25.
Yes.
And then we have 30 multiplied by 12 multiplied by 0.95. Did you miss that 12?
I think so. Because
Yeah,
that's
doesn't.
multiplied by 0.95.
This is 4163 dollars.
30 dozens, yeah. Sorry. I was just reading it as 30.
Question number three. And like you, are you getting it that these are not difficult? You
Yeah.
just have to read the data out. If one Bahraini dinar is 2.13 pounds, convert 4,000 dinars to pounds.
8,520.
8520, right? If 1 US dollars is equals to 0.7802 pounds, how many dollars can you buy with 300?
1,685.2.
No.
384.5.
Yes. Where did you go wrong?
I don't know. I redid it, but I was doing the same thing I did before. I was just dividing 300 by 0.7802.
Yes. So 384.5 dollars. Last one. An American tourist visits South Africa with $3,000. The exchange rate when she arrives is $1 is equals to 12.9 rands. She changes all her dollars into rands and then spent 900 rands per day for 7 days. She changes the rands she has left back into dollars at a rate of this. You see, rate is changing at different times. How much does she get in dollars?
2,505.8.
Very good. 25,000, 2,505.8 dollars. Okay. We still have time. I think we can do that. These questions which were left. The two short sides of are right angle triangle are 3.7 centimeters to nearest millimeter and 4.5 centimeter to nearest millimeter. Calculate the upper and lower bound for the area of triangle. Uh, can you share what lengths are you using? 3.7 upper and lower?
Oh, 3.7 plus 0. Nearest millimeter.
Yes.
Hmm. Times by 10. 37 plus 5. No,
See,
37
uh,
plus 0.5. Sorry. 0.5 and then 4.5,
you're
45.
changing it into millimeters?
Yes.
Okay.
So 37.5 times 45.5 divided by 2. Um,
Oh, yes. The question also says to change into millimeters. So we'll use these values. Now solving for upper and lower bound of areas.
so upper bound is 42.5.
For area 0.5 into 37.5 multiplied by 45.5.
Divided by 2.
Area of triangle.
Yes. And so base times height 1/2, right?
Yes.
That was what I was. Okay, let me try again. Now I'm getting a different answer. Even though, okay, I got 853.125.
Yes, this is it. So upper bound is 1 by 2 into 37.5 into 45.5 and we get 853 and it says to the nearest millimeter. So this is 853.
And length of the
And
hypotenuse.
for the lower bound also, this would be 1 by 2 into 36.5 into 44.5 and lower bound I'm getting 812.125. So keeping it 812. Length of our partners.
Upper and lower bounds. So
Yes.
47 point. Fifty, 58, 59.
That's right. 58.996. So rounded to the nearest millimeter is 59. And in the same way, we'll just use different values, 36.5 and 44.5 to get 57.55, which is 58. We did this question 9 yesterday. Let's see question number 10. Quantity x is 45 to the nearest integer. Quantity y is 98 to the nearest integer. So when they say nearest integer, that means whole number, we are talking about 1. So plus minus 0.5. Calculate the upper and lower bounds for x as a percentage of y to one decimal place.
Okay. So X could be 44 point.
So we're looking at this formula. So upper bound, what value of x and y should we use
X could be 44.5,
for upper bound?
45.5,
45.5 and y should be
98.5,
97.5
8.5. Oh yeah, since it has to be less.
to get the higher value. So I'm getting 46.6%
So we can just write 47%
and lower bound.
is 44.5
That's right.
and then divided by 98.5.
Times 100 is 45.2%. 11th. The following five masses are given to three significant figures. Calculate the upper and lower bound for the mean of these masses. Okay. So calculate the upper and lower bound for the mean of these masses. They're already given to three significant figures. If I have to write upper and lower bound when I'm looking at 138, do we understand that this is to the nearest to 1? That
Yeah.
should be 138.5 and 137.5.
Yes.
Okay, these are five different values. I'm just writing that this is plus minus 0.5.
Yes.
And The last one is, second one is plus minus 0.05. And these are written to three significant figures, and this is plus minus 5. Any objection with the third value? Plus minus 5.
No, because the zero doesn't really count.
No, that should count, but we know that this is three significant figures. So first digit 1, second 0, third 9. Ninth digit, the place value is 10.
Yes.
So that is why we're taking half of that. And again, plus minus 0.5. And at the end again, plus minus 0.123 zeros and then 5. Now for the upper bound, what is actually happening? I'm not going in that detail, that 138.5, 94.55, 1095, and so on, so on, so on, because we know we're just going to add them and divide it by 5 for the average. So I'm just adding the actual values, which is 138 plus 94.5 plus 1090 plus 345 plus 0.354. I've added the actual values. Now, may I add all these accuracies, uncertainties which are given to get the upper end?
Mm-hmm.
So now I'm adding, the first one is zero point 0.5 plus 0.05 plus 5 plus zero point 0.5 plus 0.123 zeros and 5. And I get a total of 1673.9045. Divided by 5 is giving me a mean of, upper bound mean of 334.7809. Now using those same values but with a negative sign, like 138 minus zero point 0.5. So changing the signs of uncertainties with a negative, you can use a single bracket. And divided by 5. So I'm getting lower bound as 332.3607. Try question number 12. Is the question clear?
Mm-hmm. So for the upper bound, I got 117.84, and
That's
then
right.
the lower bound, and yeah, 115.2.
115.
Yes. Let me just redo that.
Let me also try that again.
Yeah, same answer.
I'm getting 117.36.
Okay, I'm gonna try again.
This is 0.245 and minus 0.0005. So
Yes.
you get 0.2445.
And then, so it's 117.36, right?
Yes. Be very careful when you add this 0.0005. If you mess up with 1 0, the whole question is gone. And give your answers to two decimal places. The answers were already in two decimals. Last one. A cuboid of height h has a square base of length a. In an experiment, A and H are measured as 4 centimeters and 11 centimeters respectively, each measured to the nearest centimeter. What are the minimum and maximum possible values of volume? Thirteen A part. Volume is area of base into height, or let's say length into breadth into height. And we know that it is a square base, so that would be A square into H. For upper bound, what is the value of A?
4.5.
4.5. And height is 11.5.
I got 232 point, actually 233.
That's right. So 232.875 equals to 33 centimeter cube. And the lower bound
About
is
128 point, actually, yeah, 129.
right. B part. In another experiment, the volume of the block is found to be 350 centimeter cube, measured to nearest 50 centimeter cube. So volume is 350, nearest 50, and its height is measured 13.5 to nearest 0.5. What is the maximum minimum possible value of A? So first we write the formula. Volume is A square H. So when we are talking about A, let me make that subject. V over H square root equals A. So for A max, V over H, and A minimum, V over H. So for A max, what is the value of volume?
300 the nearest 50. So three, so 375.
Very nice. So 350 plus half of that is 375. And what about height? What value should we use to get A max?
Uh, 13.55.
You see, this is to nearest 0.5 centimeters.
Oh, so
So
14.
half of that is
Um,
0.25.
yes.
So we're using the lower end of height to get the maximum value of A,
So 13.75. Maximum. So 14.
13.25. Basically, what are we doing? We are doing 13.5 plus minus 0.25. So either it is 13.25 or it is 13.75.
Yes. Okay. So
And
13.2.
yes, 13.25 in order to get maximum value of A. So square root 375 by 13.25. And I'm getting 5.8
Yeah, 5 point.
centimeters. 5.3199 approximately equal to 5.3 centimeters. And for the minimum, what values do we use? Higher end of the height and lower end of the volume.
325. Yes, and 13.75.
4,
4.86. Yeah.
last part. How many significant figures should be used to give a reliable answer for the value of A?
2.
Okay, that's right. So whenever you actually see the data, we try to keep it same or one more than that. So
Hmm.
there is 2 significant for volume, 2 or 3 because 350 could be 2, it could be 3. And 13.5 is clearly 3.
Those 3 significant figures.
Your 3 would be better. So no homework for today. And
Except for drawing the graphs.
yeah, thank you. And what do we say? Like for this week, try and give a quick revision for what we did. And I think I requested Sakashif to add your email.